Yes, so what I was telling, okay, now we'll discuss about the STU and PDU. So in right yesterday we discussed about the FDMA, TDMA, OFDMA we have to discuss in details. So when we'll start the LTE frame architecture, that time we'll discuss about the OFDMA. Now next concept we are discussing, so STU service data unit and the PDU. So what I'm telling, okay, when we'll do the 3GPP decoding or we'll analyze your traffic between the layers, when we'll go through the specifications, so you will see the entire layer transaction will be explained in the terms of STU and PDU. So this portion coming in the second class, but I'm telling you this is very important for your entire course to understand what is the meaning of STU and PDU. So if you see in any communication system, as I said, definitely in every communication system, it's a two device who will exchange the information. So we have seen that in any communication system, there will be two devices which will be involved to exchange the information, means sender and receiver. Suppose when we see in the 4G technology, we will see your mobile will communicate with the EUTRAN. EUTRAN will communicate with the core network. So there will definitely one entity will work as a sender, another entity will work as a receiver. So how they will exchange the information? So between this within this device, means within the sender device or receiver device, your entire information will be processed by three layers. Layer 3, layer 2, and layer 1. So obviously in the peer-to-peer communications, if you understand peer-to-peer communication, means sender is communicating with the receiver, means receiver must have the same protocol, means receiver also have the same protocol, L3, L2 and L1. Now how this device, means sender device, will communicate with the receiver through these layers, but how information will be processed, layer to layer, how the information will be processed, means suppose if your sender has to transmit, say, some information, say info. So this info layer 3 will receive from the higher layer, and then layer 3 has to send this information to layer 2. Layer 2 will send information to layer 1. How? So when any layer will receive the information from higher layer, so each layer is having their functionality. Suppose if I ask you, can we go and watch the movie? So before giving your answer, in your brain, there are different nerve system and which will have their own functionality. Once it will be processed properly, then you can give your answer. Same thing here, each layer is having some task. So when any layer receiving the information from higher layer, these layers will perform their task. Suppose as a layman I can say right now, layer 3 will see in future it will perform the radio resource management task. So when the information will come, whatever the radio resource management task will be done, that will perform by the layer 3. Suppose layer 2 will perform your uplink synchronization, how your mobile will synchronize with the network, that layer 2 will perform. Your error correction will perform by the layer 1. So different layers, just given on some simple example. So each layer like this, there are so many tasks that will be performed by all these layers. So when any layer will receive the information from higher layer, these information will be processed by those tasks. So for time being, because our task is right now not to teach the L3, L2, L1, that L3, L2, L1, all these layers will come separately. I'll teach in more details. Right now our concentration is to understand what is the meaning of STU and PDU. So whatever the functionality layer 3 will perform, say I'm telling the layer 3 is adding the information, say H3. Suppose layer 3 is adding the information, say H3. Layer 2, for example, adding the information H2 and say L1 will add the information H1. Just as example. So when layer 3 will receive the information info, now which information layer 3 will transmit to layer 2? It will transmit info plus S3. Directly you cannot see because in most of the places in the book they will write layer 3 will transmit the information to the receiver layer 3. When you see in the suppose call flow, you may see in some message, your mobile can transmit the layer 3 message of the RRC connection request to the Inode the RRC. You may have seen this kind of call flow. Suppose UE RRC. What is RRC and all these things that will come later on. Just I'm telling example. But this as a reading the call flow, it's fine. But layer to layer is not transmitting the information like this. We cannot say it directly RRC layer or say like L3 will directly transmit to the receiver side. No. If layer 3 will directly transmit to the receiver layer 3, then what is the use of layer 2, layer 1? Because that information is not coming to layer 2. That information is not coming to layer 1. Then how the forward error correction will be modified, how this error will be decoded without coming to the layer 1. So obviously all the information has to be transmitted from the higher layer to lower layer. So when this information received by the layer 3, this layer 3 now add the header S3. So this become info plus S3. That will transmit to layer 2. Layer 2 now receive info plus S3 and then adding the header H2. So now layer 2 is transmitting the information info plus S3 plus their header. Now what will be the information in the header and all these things that you please don't ask right now, because when that corresponding layer will start, we'll see those information. Then layer 1 will again same part, they will receive this information, add their own functionality, add their own header. So at last info plus S3 plus S2 plus H1. Actually this is the information that will transmit in the radio frame. What we see in yesterday concept radio frame. So in radio frame this information will be filled and then this information will transmit over air interface and then receive by the receiver side in the layer 1. Now when layer 1 will receive this information, now the understand the meaning of protocol. So sender layer 1 add the rules H1. So out of all this entire information, receiver side L1 will understand only H1, because to understand H2, one second. To understand H2, receiver need the L2 protocol. Why? Because sender L2 add the information H2. So L1 cannot understand H2, L1 cannot understand H3, L1 receiver, same protocol, same layer, can understand only H1 and rest of the information, info plus S3 plus S2 will transmit to the layer 2. Then now same as today here, L2 out of this information decode only H2 because corresponding layer sender side L2 they send H2, so receiver receive the H2. Then what left, info plus S3, here S3 will be decoded. What left, info. See, you transmit the info, they receive the info. But before transmitting and receiving the info within your motherboard, within your chipset, all these layers will have to perform their task. So that's why in the college time or in somewhere in the Google you may see this kind of communications. Layer 3 is communicating with the layer 3, layer 2 is communicating with layer 2, layer 1 of sender is communicating with the layer 1. That's we can derive this concept, but directly it's never possible that sender layer 3 will directly communicating with layer 3. Why we make this concept? Yes, derive concept. Why? Because the sender layer 3 transmit S3, receiver layer 3 receive the same information, so that we can say L3 communicating with L3. इसलिए आप लोग लिखते हो कॉल फ्लो में UERRC send the RRC connection request to the Inode BRRC, but directly it cannot go. If you go in details, first within your mobile, it will go from higher layer to lower layer, then again this is our side, lower layer to higher layer, then at last corresponding information that we'll see later on when the layer will start to the corresponding layer, only the corresponding protocols. So now layer 3, what they transmit, receiver layer 3 receive, so we can say layer 3, layer 3. Layer 2 transmits, layer 2 receive. What layer 1 of sender transmit, layer 1 of receiver has received. So this is called the peer-to-peer communication. So this is a standard, whether it's a 2G, 3G, 4G, or if you go in 5Gs, whatever technology, this theory is not going to change. Every time that two devices will communicate, whether you're working with the Bluetooth protocols or whether you work with the Wi-Fi protocol, this story will remain same. It is not going to change this concept. Now here, what is the meaning of Stu and Pdu? So simple, understand what any layer is receiving, the information, what any layer will receive is called Stu. What you will transmit, what the layer will transmit, so what layer will transmit, that information is called Pdu. Because this Stu Pdu concept is very important, especially when we come to the RLC layer, MAC layer, that we have to understand their Pdu structure. In that Pdu, what are the Stu form, what is the Stu size, what is the amount of the Stu transmitting one frame. So that's something, this is very important concept. So Stu and Pdu, so what any layer will receive, that is Stu. What you will transmit, when that layer will transmit, that is called the Pdu. So suppose if we are talking about one layer, say with the same example, if I am taking here, say your layer 3. In layer 3, what we have seen, it's receiving the information info. What this layer has transmitted, info plus S3. So if we have to discuss about this layer 3, so in layer 3, what is the SDU? What this layer is receiving? You're receiving info. So for layer 3, info is SDU for layer 3. What layer 3 is transmitting? Info plus S3. So what you are transmitting, that is the PDU of that layer. So this info plus S3 is the PDU of layer 3 and info with the STU of layer 3. Now go to the next level, again come down to the another layer. Same layer 2. Now your layer 2 is adding the header, say S2. Now concentrate here. So in layer 2, what you are receiving? Now focus on this layer. What we are receiving? Info plus S3. So same info plus S3 can be the STU of but layer 2. See, it become info plus S3 is the PDU of layer 3, but same info plus S3 can be the STU of layer 2. Next, what layer 2 is transmitting? Info plus S3 plus S2. So what you will transmit? Layer 2 is transmitting this information. So it becomes the PDU. Which layer is transmitting this information? Layer 2. So PDU of layer 2. Same way it will keep continue for the layer 1. In layer 1, what you are receiving? Same information we are receiving. So this become the SDU, what you are receiving, but SDU of not layer 2, SDU of layer 1. PDU of layer 2, the same information becomes the SDU of layer 1, and then again you add the H1, again you transmit, that becomes the PDU. Like this will be going. This is the meaning of PDU. H2. A simple way to understand any layer what is going to receive from higher layer, that is the SDU of that particular layer which is receiving, and what that particular layer is going to transmit, that becomes the PDU. So is it clear, the meaning of SDU and PDU? After clear here? Now next.
Yes, sir.
Next we have to see here. So now the same concept we have to use in your LTE protocol stack communication. So if you'll see in the end-to-end network architecture of LTE, your UE is communicating with the EUTRAN, and EUTRAN will communicating with the EPC, Evolved Packet Core. Because to understand the protocol stack architecture, first of all, let's understand the network architecture. Then based on this we'll understand how this entity will communicating through which protocol. So in now I'm coming to your LTE architecture. Here we'll discuss about the LTE frame, all these things. So in whatever you see your earlier communication system in 2G or 3G, I think every communication system, now 5G came even though it's a compulsory, your mobile has to communicate with the RAN, and RAN will communicate with the core network. In 2G, your mobile was known as the MS mobile station, and that time RAN is known as the JRAN, GPRS Edge Radio Access Network, and the core network. When we move to the 3G, obviously 2G was offering the 13.8 kbps, in 3G we need the higher data rate. So whatever the protocol your mobile was supporting, obviously that protocol has to be changed. And if your mobile protocol will change, then obviously RAN protocol also upgraded. So that's why in 3G, your mobile was knowing UE. And if you see the RAN evolution in 3G, see RAN here GRAN, in 3G it's become UTRAN. This RAN has upgraded as the UTRAN, and core network, luckily in 3G core network is the same, your 2G and 2.5 means GSM and GPRS core network was upgraded the same way to provide the support the service in 3G. So in the core network there is no too much more development in the 3G when we move from the 2G to 3G. But 4G network is completely designed. See, I'm not spending time on the 2G, 3G, just I'm coming to our contents. So 4G is completely designed for the PS service. It does not mean that we cannot make the voice call. We can make the voice call, but for enabling the voice call when your release 8 specification has come, there is no features given the LTE to offer the voice call by using the LTE network topology. No, to make the voice call in LTE, you can use the existing 2G or 3G network. Yes, so what I'm telling, if you see your 2G was completely designed for CS service, 3G was designed for CS and PS both. That's the reason in 3G, in core network, we have two domain, CS domain and PS domain. So that if your mobile, suppose I'm just giving one very simple example, because we don't have that much time to spend the time in 2G, 3G. Just one simple example, suppose in your 3G mobile, if you're getting the video call or 4G mobile anywhere, if you're getting the video call, if you're getting the Skype call, if you're getting the WhatsApp call, if you're getting the real-time voice call, How this different call will be differentiated? Because see, WhatsApp call means you need the internet. If you need the CS call, CS means a circuit switch that does not need the internet. So whether any call came for the CS call or PS call, how your mobile will know? Because suppose your mobile right now in idle mode or getting some call from the network, but suppose any of your friend is calling, so it's a network job who will inform your mobile if some call is coming to you. How? For that we'll see in layer 3 there is paging procedure. So network will inform the mobile by sending the paging message, this is layer 3 message. But how mobile will know that call is for CS or PS? That's the reason they will within those call message you will see there will be one element. Suppose if network is sending what I said is, suppose if your mobile is having any call CS or PS whatever, so definitely they will send the message, paging message, because paging is a procedure through which network will inform your mobile about incoming call or incoming data, anything, because now your mobile in idle mode. So if you're in idle mode, how you will know there is any call or data for me? Obviously, before call is connecting to your mobile, first network has to inform you so that your mobile will move to the connected mode and then call will connect it or you will receive the data. Now your mobile in idle mode, so it's a Inode. First they will send the paging message, then your mobile will wake up. But in this paging message, how they will inform that this paging message came from CS domain or PS domain? So that's why they will have one element, it's called the core network domain identity. And this information element having the two possible value, either CS or PS, anyone. If suppose you are right now receiving the WhatsApp call, then in paging message core network domain identity will be the PS, so that mobile understand, okay, this is coming for the packet switch call, this is not the CS call. If you receive the directly voice call without internet, then your core network domain identity will be CS, so mobile understand, okay, this is a CS call. So that's why in 3G we have two different core networks, CS and PS domain. CS domain is using your almost existing GSM infrastructure in the core network. PS domain was using your existing GPRS infrastructure. As I said, we don't have that much time to spend the time on 2G, 3G, but we have to spend more time on 4G. So I'm giving the idea about this basic architecture. But what about this UE and RAN compared to 2G and 3G? This was completely changed. Whatever the protocol in mobile station in 2G, suppose in 2G you'll see the protocol LAPD, LAPDM, but those kind of protocol we cannot see in 3G. So UE and EUTRAN, this is capable to handle both CS and PS. Suppose if you want to make CS call, even though your path will be this only. If you want to make PS call, even though this path, same path. Yes, in core network, your CS call will terminate to this domain, and if it is PS, this will terminate to this PS domain. In core network, we have two different domains, CS and PS domain. But 4G is completely designed for PS services. Why I'm telling you? Because as yesterday I said, in 2G was offering the 13.8 kbps data rate, and this data rate is giving the very good voice quality. If suppose your call is not connecting, if you don't have a good signal strength, that is not the problem, the protocol. The network that is not the protocol problem, it is a network issue. But if you have the good network, then 13.8 kbps is the tested speed which can give the very good voice quality. So why we move to the next generation 2G, 3G, 4G, 5G? Our main concern about the PS services, packet switch service, because for packet switch services we need the higher data rate. Why? One main reason, as I said yesterday, for CS service you get the dedicated channel. Means if we are saying this 13.8 kbps means this is dedicated to this particular path. But in PS services, you can use the even shared channel if suppose dedicated is not available. Suppose yesterday, for example, we have seen only 125 channel was there. Means if 126 user will try to call in FDMA, then all channels was busy. You will listen that the channel of this routes are busy. Why? Because for voice call, suppose this channel already being used by the say Prashant, this channel already suppose being used by the Prashad, this channel already being used by the Asutosh. So if any like this, all this channel is given to one user. Now any new user will come, they will see all channels are occupied. Now whatever channel is being used by the Prashant, can a new user, suppose any new user will share the same channel? No, in voice call it is not possible. See, right now I'm not telling about the VoLT. VoLT is a different story. But general for voice call, you have the CS call, but VoLT is not CS, it is the PS. So here, if any new user will come in call, they will listen the channel of this routes are VG. Why? Because for voice call we need the dedicated channel. But did you observe this kind of situation for the PS service, for internet service? You may have never observed this kind of situations. Why? Because in PS service, you may have observed your data rate is increasing. Data rate might be decreasing. But you will never see, they will say the channel of this routes are VG. Why? Because in PS service, we can use, if dedicated is not available, then you can use the shared channel as well. Shared channel means, now suppose this 125 channel, for example, if all 125 channel are occupied by one user, now suppose say 126th user will come for PS service. Don't worry, you use this channel what Prashant is using. So obviously understand, that's why in your PS service, your data rate is keep changing. Sometimes you'll see suddenly 20 Mbps, suddenly 2 Kbps, again 10 Mbps. Why? Because in the real time, when you see there are million number of subscribers, so many users can come at the same time for call or data transmission, or so many users maybe they can release the call. So suppose here, if I say कि for 126 user, now all channels are busy, resource is not free, then what will happen here? Don't worry, whatever the channel Prashant was using, use the same channel. Like I'll tell this all resource allocation mechanism. Your mobile will not decide, it's a network who will decide, because network is knowing that Prashant is transmitting less data or Prashant is transmitting more data, Asun is transmitting less data. So this is network is knowing. With one network, multiple mobile is connected. You are not knowing. Prashant is not knowing because Prashant is consuming less data. Prashant is not knowing that Asun is consuming more data. Asun is not knowing about the Asutosh. So these people are not knowing about each other. But with this network, all mobile are connected. So network is knowing about all this mobile. Okay, they are using the Skype call, they are using the downloading movie. This Asutosh is watching the IPL cricket match. So network is knowing. So network know very well to which user we should give more resource and which user we should allocate the less resource. So now when this 126 user will come, depends upon your request. It's a network who will tell, okay, you use, say suppose this channel. So now earlier Prashant was using this channel, complete resource, but now same resource is being shared by the two user. Then definitely whatever the data rate Prashant was experiencing earlier before 126th user has introduced, now obviously compared to that, now data rate will be reduced for him. Again suppose one more user will come, more data rate will be reduced. Now suppose 126 user, their data transmission over, they will leave this connections, then data rate will increase. Why? Because now same resource can be shared by only two users. Earlier it was 3 users. So that's why in the PS services, your data rate can increase, decrease in all these things. But in CS service is a dedicated. So here in 4G, what we observed here, because when we move to 2G to 3G, our main concern, why we need the higher data rate for the PS services. Because PS user can use the shared channel, So imagine with the 13.8 kbps data rate, and this is also a shared link. Effectively, maybe you get the 1 kbps, less than 1 kbps, maybe 0.1 kbps, depends upon number of users. So that's why this data rate was not enough. So that's why generation to generation, our main concern was to increasing the data rate, but increasing this data rate mainly required for your PS service. So when 4G has designed, 4G is completely designed for PS service, because there was no problem for CS service. For CS service, we have the good data rate. Problem was for the packet switch service. We need higher and higher data rate. Why? Because number of users keep increasing. As many number of users will keep increasing on the one channels, more load will keep increasing. So maybe when the 3G has came with the 2 Mbps, even though after some years it was not enough, because more number of subscriber has increased. So 4G has designed completely for the PS services, packet switch services. So the first point we can say LTE is completely designed for PS services. But again, it does not mean that you cannot make the voice call with the LTE. You can make for the different solutions. You have the CSAB, you have SRVCC, we have the IMS IP multimedia subsystem, that is your more popularly known as the VoLT. So we have the different solutions for voice, but LTE is completely designed for PS services. For CS, either we can use the 3G 2G network, or if we want to transmit the voice in the terms of packet, then we can use the another technology, IMS, that's called the VoLT. But LTE network, when the first generation their LTE release 8 has came, it was completely designed for the PS services. So now, if what I say in UMTS, you have seen UE, UTRAN. In 3G, in UMTS you have UE was communicating with the UTRAN. So UTRAN means what? It was having the BTS and BSC. Sorry, Node B and RNC. So Node B is doing the same functionality what you are knowing about the BTS in GSM. RNC is the same thing what you know about the BSC in GSM. So combination of Node B plus RNC is UTRAN. Then, as I say, in the core network you have two domains, CS domain, PS domain. As I said, we are not spending too much time on 3G. So when we came to the 4G in LTE, the first thing in LTE, your UE, and RAN has again upgraded as the eUtran. Here UTRAN, here evolved UTRAN, eUtran. And here core network is known as the evolved packet core, that's called the EPC, evolved packet core. So what is actually main difference here compared to UMTS network architecture in the LTE network? First point I said, LTE is completely designed for PS service. Second very important point, see in your UMTS, RNC is very important. Your entire radio resource management task, your MAC layer functionality, RLC layer functionality, all those tasks will be done by the RNC layer. Only few functionality of physical layer and MAC layer of the few functionality will perform by the Node B. Otherwise, all other functionality will perform by the RNC layer only in UMTS. But in LTE, there is no RNC. First, again, next point, in LTE, there is no RNC. Then the next point will click in your mind, sir, if there is no RNC in LTE, but RNC is very important, The entire radio resource management means radio resource allocation, deallocations, your traffic management, your traffic segmentation. Data is coming from higher layer to lower layer. So how that will be segmented, reconcatenated, everything will control the RNC. So if RNC is not in the EUTRAN, then who will perform this task? So in LT, it is the E node B. Here node B in LT is upgraded as E node B. So in LT, EUTRAN is having one or more than one E node B. So suppose E node B 1, E node B 2, I am showing here 2 E node B. It may have multiple E node Bs. So EUTRAN may have one or more than one E node B, but there will not be any RNC in LT. तो फिर RNC का feature कौन करेगा? Who will perform the functionality of RNC in LT? So that's why it's called the evolved E node B. Whatever your UMTS node B, that was upgraded. How upgraded? Entire RNC functionality they embed in the new node B only. They mix both together and make one simple unit that is called the E node B. So that's I'm telling, if physically RNC is not available, in books say कि RNC is not available in LT, but I am modifying that point. You can say physically it is not available, but functionality wise RNC is very important. So their functionality has implemented within the E node B. So that's why it's called the evolved E node B. So then now next question is coming, okay, why we are embedding the RNC functionality to the E node B? What is the benefit? So for benefit, you understand one point. For packet switch service, most of the packet switch service, PS service, transmission based on acknowledgement, so that information may not lost. Suppose your example, when you're in the voice call. So voice call is kind of real-time service. Part of you, if you suppose speak, I couldn't hear. So some information has lost. So there is no protocol in your mobile who can retransmit the same words. Okay, this receiver could not listen this word, so we should retransmit. Unless until you will again speak. But there is no protocol in your motherboard who will check each word receiver receive properly or not. No, chalo, this word could not receive, so again this word should be retransmitted by your mobile protocol. No, for voice there is no retransmission. If lost means lost. But PS transmission is based on the acknowledgement. The example is, suppose most of the PS service, suppose example, when you are in the sending the mail to any of your friend, it will never possible that you will receive half mail. It may take some time to reach you or your PC or your mobile, but definitely when you receive the mail, it will be the complete mail. It will never possible that you will receive half mail and half packet is lost. Why? Because most of the PS transmission is based on acknowledgement. Means if sender is transmitting any packet, suppose if you have packet P1, P2, P3, multiple packet. So say if sender transmit one packet, say P1 to the receiver, then first receiver have to send the acknowledgement. That acknowledgement can be positive, ACK, or it can be negative, NAC. NAC means I could not receive. So receiver has to inform to sender, I receive, not receive. So if suppose not receive, for example, then again P1 will be retransmit. If suppose ACK, receiver said yes I receive, then transmit the next packet, because P1 already received, now transmit the next packet, P2. So your packet switch transmission based on acknowledgement. So receiver here in PS service, there is very less chance for data transmission loss. But there is one problem. Reliability wise is okay, fine. It's a reliable transmission. But delay has introduced. How delay has introduced? See, you transmit the packet in earlier for voice call, you keep transmit packet 1, packet 2, packet 3. You are not waiting for the acknowledgement. Why? If lost means lost. But here sender is waiting for the acknowledgement. Receiver will again take some time to transmit this acknowledgement. After this, again suppose negative acknowledgement, same information you are retransmitting. So obviously it will take more delay. But as I said, depends upon the different types of services. We have to understand whether here we need the reliable transmission. So for reliable transmission, if some delay has introduced, okay, fine. For some kind of service, we say, okay, reliable transmission not required, but we want for this service very less delay. We cannot tolerate the delay. Suppose, as I say, real-time voice call. Already I am there in the another side with you. So if I could not hear anything, I can say, na, okay, please, Astos, again tell me these words. I couldn't hear you properly. So that time we should not need any protocol who will retransmit the missing word. But here in PS services, retransmission required, it will take some time, so delay is introduced. So depends upon the services where delay is required or not required, where we can tolerate the delay or we need the reliable transmission. Depends upon that requirement, your different types of services will divide into the different transmission format. But in PS service, most of the service you understand, acknowledgement is required. So now understand, LT is offering the higher speed than the UMTS. So suppose if you could have RNC here in LT, suppose in LT also have the RNC. So earlier in UMTS, in 3G, what was happening? That is called the RAN. So if you're transmitting any information to RAN, so first transmit the packet 1 mobile to node B, then packet 1 from node B to RNC, then RNC have to send the acknowledgement to the node B, whatever acknowledgement, positive or negative. Then a node will send the acknowledgement to the UE. So it was taking additional time. Here node B to RNC, if we can implement the RNC within the node B, that become Inode B. So now directly point to point, this additional path time has saved. This round trip time means node B to RNC and then RNC to node B. This round trip time has saved. So this will affect your data rate improvement. So that's why in 4G, the functional wise, RNC is implemented to node B. Physically, there is no RNC in LT. I hope it should be clear. So there is physically, there is no RNC in LT, but their functionality will be implemented to Inode. Now I'm showing this solid line path and dot line. What does it mean? Solid line tooling is showing that between UE to Inode B, your user traffic can transmit. Dot I'm representing the signaling transmission, means your mobile in LT can transmit the signaling information as well as the user traffic information, both information to the Inode B, both type of information. And one Inode B can communicate with the another Inode B by exchanging the signaling information or user traffic information. अब ये कब communicate करेंगे, how they will communicate, so all these things we'll see in the handover. I'm not teaching the handover. But during handover, your Inode B1 can communicate with the Inode B2 by forwarding the user data, or obviously to perform the handover, signaling process is required between one Inode B to another Inode B. So signaling and user traffic both can be exchanged between one Inode B to another Inode B, and then interface is the between Inode B to Inode B. The interface is X2 for user plane, more particularly it's called the X2U. For control plane it's called the X2C. Here on the air interface it's called the LTE interface. Now so if you will see here, your mobile RAN and then communicating with the core network. So there will be multiple RAN, which all of you from the other backgrounds know. With multiple RAN will communicate with the core network. So the LTE core network, these two entities are very important. MME and serving gateway. Why? Because MME is the entity who will handle mobile signaling information within core network. MME will handle only signaling information, no user traffic, only signaling. But again I am repeating, directly mobile cannot communicate with MME, via Inode B only. So with one MME there can be multiple Inode B. Here I am showing the two Inode Bs, multiple Inode Bs. Under one MME, multiple Inode B can connect it, and with the again with this Inode B there will be multiple UE. There will be multiple UE. Means your mobile signaling information in the RAN will be controlled by the Inode B. Mobile user traffic information will be controlled by the Inode B in the RAN. But in the core network we have two separate entities. MME will handle the mobile signaling information in the core network, and serving gateway will handle the mobile traffic information. But as I said, directly it cannot go mobile to serving gateway. Anyhow it will go via the Inode B only. So I said Inode B can receive the user traffic or signaling both. Then Inode B will transfer the signaling to the MME and the user traffic information to the serving gateway. So what are the signaling information MME will handle? That we'll see in the NAS layer. Suppose your registration procedure, mobile attach procedure, detach procedure, tracking area update procedure. We'll see so many call flow that will be handled by the MME. So that is NAS layer procedure. So your NAS layer, I will tell what is it. It's right now. Sorry, I should not use NAS layer. I didn't tell NAS layer until after some time NAS layer. So your few parts of layer 3 signaling will be controlled by the MME. So we'll see about those procedure when the layers will start. Right now just telling about the component that you use in the your LTE network architecture, and then serving gateway which will handle your user traffic information. So now if you will see here, what you understand in the terms of network architecture, your mobile is communicating with the RAN. Protocol communication means what? Now we have to understand within this UE what are those protocol which will help to communicate with the Inode B protocol. If mobile is communicating with the Inode B without protocol, without layer 3, layer 2, layer 1, they cannot communicate. So they will communicate with that only, with the protocol. So in protocol stack architecture we have to understand about those protocols. So just now I said your mobile communicating with the Inode B, and mobile few signaling information will be communicated by the MME also, but via Inode B. Means your mobile can communicate with the RAN and mobile can communicate with the your EPC, means core network both. It means your now coming back to this topic, your LTE protocol stack architecture. So what I say in the your network end-to-end communication, what we have seen, your mobile is communicating with the RAN, and there will be so many signaling procedure of the mobile that will be communicated with the MME. Means your mobile can communicate with RAN and core network both. But while mobile is communicating with the core network, what I said, directly mobile will not communicate with the core network. Communication is possible via Inode B only. So your mobile must have two types of protocol. Core network protocol and radio protocol. Your mobile must have two types of protocol. This is your UE protocol. I'm telling the high level design. I'm not telling the exact layer. I'll tell the exact layer after this diagram. So this is your high level design of LTE protocol stack. So your mobile is your mobile. Mobile will have radio protocol. Why? Because mobile radio protocol will communicate. See here, over the air interface, your mobile is communicating with the RAN. So mobile radio protocol is used to communicate with the EUTRAN, and just in the beginning of the class I say peer-to-peer communication, same protocol. So EUTRAN must have the same protocol. Here sender side radio protocol, then EUTRAN must have definitely same protocol, radio protocol. EUTRAN will not have core network protocol. Why? वो just ऐसे कि mobile core network protocol is used to communicate with the core network, means EPC. So here you actually in EPC with which it will communicate MME. In EPC with which entity your signal will exchange with the MME. So EUTRAN with the radio protocol, mobile radio protocol communicating with the EUTRAN radio protocol, same C. Today in the first class I Stu and Pdu. Two entity will communicate via same protocol only. Here radio protocol, definitely here radio protocol. Then EUTRAN will communicate with the MME via S1AP protocol. So MME must have here S1AP protocol. Then mobile core network protocol, that's I'm telling right now NAS layer actually. So whatever the NAS layer procedure, core network protocol procedure, those procedure mobile will use to communicate with the MME. So definitely here MME will have the core network protocol. And again peer-to-peer same protocol communicate, mobile core network, MME core network, mobile radio, EUTRAN radio, S1AP. अब देखो anywhere two different devices communicating through the same protocol. But again I am repeating, here in the diagram I am showing here direct, but directly mobile control protocol directly cannot communicate with the MME control protocol, because between that there is Inode B. What I want to say, suppose for example I am saying just now, see how that your information flow of information understand. Say suppose you have some information, info you have to transmit. So just for saying Stu and Pdu, each layer will add their own header, say core network protocol is adding the header, say suppose C. So your mobile higher layer core network protocol will transmit which information, info plus C. Now your mobile radio protocol will add their own header, say R. Then what information will transmit on the air? Info plus C plus R. Now in receiver side we have radio protocol. So radio protocol understand only R. Why? Because radio protocol transmitter transmit R. So receiver side having the same protocol, radio protocol, they understand R. What is R? But radio protocol cannot understand C. Why? Because to understand C, EUTRAN must have core network protocol, but EUTRAN does not have core network protocol. So radio protocol क्या करेगा? Within the EUTRAN, they will forward this information to S1AP protocol. So what information left? Info plus C. R has already decoded. Info plus C left. Now S1AP protocol cannot understand what is C. So they will also forward by adding their own header. Say suppose the header is say S. So info plus C plus S has transmitted. Now in MME, out of this S1 AP transmit S, here they understand what is S. Rest of the information, info plus C, they transmit yes. Now here MME core network protocol can understand what is C. Why? Because core network protocol sender transmits C. In MME we have same protocol, so they understand what is C. You decode C, whatever left, suppose say info. So I'm telling what you're transmitting here C. In MME core network protocol receiving C, so that's I'm showing this path. But you never think that here core network protocol, when this is the info, directly from here they transmit to MME. No, that is wrong. Anyhow it will go via Inode B only. Then why making this diagram? To showing yes, mobile core network protocol is communicating with the MME. Please remember, EUTRAN does not have core network protocol. EUTRAN will remain transparent for core network protocol. You will transparent. Transparent means whatever information came from the core network protocol, EUTRAN transmit as it is. They transmit. They did not do anything. Will be transparent for core network protocol. So now in the low level design we have to seek yes, what are the layers that will work as a radio protocol, what are the layers that will work as a core network protocol. So then next we'll see about the low level design in the tomorrow class. So till now this topic not completed, tomorrow it will complete. So if you have any doubt about the protocol, please ask the doubts tomorrow, because till now it's not completed. So tomorrow we'll see this topic in more details with their corresponding layers.